James Webb Space Telescope detects sounds. We give you the most cordial welcome to this new documentary. If it is the first time, I introduce myself. I am the engineer Hiddekel Morrison, and I appreciate you decide to see this educational content. In this new installment we will see the image of the so-called ghost galaxy, and we will listen to the sounds of the universe from the first images taken by the James Webb Space Telescope. Join me, thanks to applied technology, in this new educational adventure. From the perspective of an engineer. Let's start. The United States Space Agency, NASA, has just unveiled the sounds it has detected in space, applying a new immersive way to explore some of the first full-color infrared images and data from the James Webb Space Telescope now to through sound, whereby one can enter the complex soundscape of the cosmic cliffs in the Carina Nebula, explore the contrasting tones of two images representing the South Ring Nebula, and identify individual data points in a transmission spectrum from the hot gas giant exoplanet called WASP-96b. A team of scientists, musicians, and a member of the blind and visually impaired community worked to adapt the Webb data, with support from the Webb mission and NASA's Universe of Learning, achieving an exciting sound representation of what the James Webb has recorded so far, which we hear below. But first, I ask you to support us by liking this video, sharing this video with your contacts, and subscribing to this channel, turning on notifications, so with your support, we can continue to frequently generate interesting documentaries on aerospace technology and the universe. Thank you for contributing to the creation of educational content. Our goal is to make Webb's images and data understandable through sound, helping listeners create their own mental images. Matt Russo, musician and professor of physics at the University of Toronto. To achieve the sounds that we will hear, a process known as assigning data to sound was carried out, that is, the data detected by James Webb were taken, with which these images were recreated, and a sound assignment was made to these data, converting them into musicalized sounds. These spectacular and historical images and detected data. Listen first to the sonification of a near-infrared image of the cosmic cliffs in this nebula called Carina. Nebulae are regions made up of gases, mainly hydrogen and helium, as well as chemical elements in the form of cosmic dust. They have remarkable cosmological importance because many of them are the places where stars are born. Significant expanses of massive gas that were initially seen in Hubble Space Telescope data can be seen in this Carina Nebula, but that we can now appreciate in high resolution and mapped with sound, thanks to the James Webb Space Telescope, which allows us today to hear how the musicians assigned unique notes to the semi-transparent and diaphanous regions and to the very dense areas of gas and dust of the nebula, culminating in a buzzing soundscape. Let's hear it. Scientists then generated the sounds in these two views of the South Ring Nebula, in near-infrared light, left, and mid-infrared light, right, and each has been sound adapted. In this sonification, which we hear below, the colors of the images were mapped to sound tones, light frequencies converted directly into sound frequencies. Near-infrared light is represented by a higher range of frequencies at the beginning of the track. Halfway through, the notes change, becoming lower overall to reflect that mid-infrared includes longer wavelengths of light. In this latest sonification, the Webb telescope observed the atmospheric features of the hot gas giant exoplanet called WASP 96b, which contains clear signatures of water, and individual data points from the resulting transmission spectrum were translated into sound. Sonification scans the spectrum from left to right. From bottom to top, the y-axis goes from least to most light blocked. The x-axis runs from 0.6 microns on the left to 2.8 microns on the right. The hues of each data point correspond to the frequencies of light that each point represents. Longer wavelengths of light have lower frequencies and are heard as lower pitches. The volume indicates the amount of light detected at each data point. Let's listen. After hearing and seeing those wonderful records of the universe, here we share the image revealed by the James Webb Space Telescope of the so-called ghost Galaxy M74. This image was shared by the European Space Agency based on captures from the James Webb Space Telescope. This ghost galaxy is 32 million light-years from Earth and is considered a favorite target for astronomers to study the origin and structure of galactic spirals. M74 is a particular class of spiral galaxy known as a grand design spiral, which means that its arms are prominent and well defined. Remember that when we talk about galaxies we mean a set of stars, gas clouds, planets, cosmic dust, dark matter and energy gravitationally bound in a more or less defined structure. James Webb has revealed filaments of gas and dust in M74's grand spiral arms, and the lack of gas in the nuclear region provides a clear view of the nuclear star cluster at the galaxy's center. The European Space Agency notes that Webb observed M74 with its mid-infrared instrument, MIRI, to learn more about the early stages of star formation in the local universe. This observation makes it possible to identify star-forming regions in galaxies, accurately measure the masses and ages of star clusters, and finally obtain information about dust grains moving in interstellar space. What do you think of the fabulous musicalization of the universe made by the team of scientists with data from the James Webb Telescope and the recent record of the so-called ghost galaxy? I read them in the comments of this video. As usual, we appreciate you informing us. It is a real pleasure to be able to provide you with the main news, trends and developments about the most important aspects of aerospace technology and the universe, from the perspective of an engineer. I am the engineer Hiddekel Morrison and I invite you to meet again in a future installment.